Thermal Comfort in a Bioclimatic Dwelling, The Habitable Device 20 Years Later, by Ignacio Teiza, Francisco Mustieles, Maria Delgado, Pablo Larroche, and Ricardo González. El dispositivo habitable, as we called it in Spanish, received one of 25 prizes in the international competition with 25 bioclimatic houses for Tenerife. The construction of these 24 houses, one was not built, was completed in 2010 and together with the visitor center are part of the complex within the Technological Institute of Renewable Energies, ITER, in Tenerife, Spain. Bioclimatic strategies informed the architectural concepts from day one. We wanted the strategies to be integrated and part of the architecture. We did not want these to be added on afterwards. We connected with the wind from the northeast and the sun to the south, with also a view of the Atlantic and psychological protection from the Teide volcano on the north. The mild climate required minor interventions, shade and air movement in the summer, and some passive heating in the winter. The building is heated and cooled only with passive strategies, no mechanical systems. To organize these strategies, we created what we called a solar regulatory system, a wind regulatory system, and a mass regulatory system. The solar system helped to provide shade in the summer and passive heating in the winter. The wind system provided air movement when needed, and the mass regulating system helped to dampen these out fluctuations inside the buildings, storing heat in the winter and in the summer working with night ventilation. Local construction materials were used, including porous volcanic stone, and renewable energy was produced with 17 panels facing south, and solar hot water was also produced with panels also facing south and a 200-liter capacity tank. The goal with this presentation is to understand if the building, after 25 years, is performing as intended. We're looking at thermal comfort and energy efficiency. We want the building to be comfortable and we want the building to be energy efficient. ITER installed a monitoring system that measures temperature and relative humidity, surface temperature, and wind speed. These are measured every minute. The images to the right show where these are located in the building. It is very clear by looking at these charts, by looking at the psychrometric chart, that the climate is mild, but nevertheless, conditions inside the building for the example year, which is 2016, are always inside the comfort zone, or in some cases in the warmest part of the year during the summer, inside the comfort zone with the air movement and some shade. So if we are inside the building and we have air movement, we're going to be comfortable. ITER also looked at energy balance. What you see on the left is the month of January, which has a negative energy balance, and the month of July, in which there's a positive energy balance. You can see on the right that there's an energy surplus, and there's much more energy over the year that is produced that is actually being used by the building. And this is with a 90.3% occupancy rate, which is a really good number. Data monitoring has allowed to analyze hydrothermal and energy behavior of the building. Conditions inside are within the comfort zone more than 90% of the year without the use of any mechanical heating and cooling systems. This demonstrates that the design strategies proposed 25 years ago are valid, and it is possible to achieve thermal comfort inside the building with passive bioclimatic measures, such as air movement and shade in the summer and solar gain in the winter. Furthermore, the building generates more energy than it uses while still providing thermal comfort. It is a living building. We would like to acknowledge everybody involved in the project, especially the team from ITER, Universidad del Zulia, the Spanish Ministry of Science, and the European Union, which provided some funding for the project.